Reminder, if you're asked to determine the trigonometric function values, all you do is set up the trig fractions, the SOHCAHTOA fractions. You don't need a calculator. If instead you're asked to solve a triangle, then you will use the sine and cosine and tangent buttons on your calculator. This video is going to talk about how to solve triangles. So first, let's talk about labeling triangles. Capital letters refer to your angles and lowercase letters refer to the sides. Across from angle A is side A, across from angle B is side B, and across from angle D is side D. I use D instead of C here, so it's obvious which is my capital letter and which is my lowercase. Okay, how can I use that to solve a right triangle? First, you label your sides with the words opposite, adjacent, and hypotenuse. Then, based on what we're given, what numbers we know, and what specific piece we're looking for, you can set up a SOHCAHTOA fraction. Next, if you're looking for a side, like in examples 1 and 2, you'll cross multiply. If you're looking for an angle, like in example 3, you'll use inverses on your calculator. And then step 4, when you're looking for sides, you'll have to type that answer into your calculator. Helpful rule before we get into anything is angles in a triangle add up to 180 degrees. And remember, the square that you see denotes a 90-degree angle. Okay, let's get to an example. Example 1, solve the triangle below. All right, I'm going to start by labeling my sides with my letters M, N, and L. So across from angle N is little n, across from angle L is little l, and across from angle M is side little m. I am given the 23-degree angle N, so I'm going to use the words opposite, adjacent, and hypotenuse based off of that angle. Hypotenuse is the L. It's across from my 90-degree angle, which is also the L. Across from 23 is my opposite side, and beside 23 is my adjacent side. All right, solving the triangle means we need to find all 3 sides and all 3 angles. So we need to find big M, little m, and little n. It doesn't really matter what order you solve for everything in. It's kind of like you have 3 completely separate problems. So let's find little m first. Purely arbitrarily chosen, no reason. Okay, to find little m, I know the hypotenuse because they give me 12 in the problem, and I'm looking for the adjacent. So I know the hypotenuse and I'm looking for the adjacent. SOHCAHTOA, you want to pick the fraction that has an H and an A in it. And that's how I know to use the CAH fraction. So set it up. Cosine, instead of theta, we know this is a specific 23 degrees, equals the adjacent side, which is m, over the hypotenuse, which is 12. Solve for m. Since we're looking for a side, we're going to want to cross multiply. If you want to write cosine over 1 to make that into a fraction, to make it super clear what you're cross multiplying, do it. You don't have to though. So take the top of one fraction times the bottom of the other, and the top of the other fraction times the bottom of the first. Now notice everything on the left-hand side is all just calculator buttons. So use your calculator. You need to make sure you are in degree mode. I am not. So in this calculator, the mode button is right beside the blue second. You'll scroll down, make sure degrees is highlighted, and hit enter. Then second mode gets you back to your main screen. And you'll notice up at the top it says degrees. Now I can type that in exactly as you see, 12 times cosine of 23, and that tells me my m value is 11.05. Okay, let's find side n. At this point, because we have a right triangle and we know 2 sides, we know the 12 and the 11.05, you can use Pythagorean theorem here to solve for n. I am going to use the same steps we just did to just reiterate the steps, give you more practice with it. And in case we made any mistakes finding m, we don't carry that over when we use Pythagorean theorem to find n. So you can use Pythagorean theorem here to find n. Now that you know m, I'm going to just do the same steps we did before. So what are we given? We're given this 12 in the problem, and now I'm looking for n, which is the opposite side. Pick out which fraction uses the hypotenuse and the opposite, and set it up. We're looking for a side here, so I'm going to cross multiply. I like to write sine over 1. And now everything on the left-hand side happens to be calculator buttons, so I can type that into my calculator. N is 4.69. You can always double check your work by doing Pythagorean theorem to make sure it all matches up. Okay, solve the triangle. We know all three sides now. Yay! The only thing we have left to do is find the third angle. We know that n is 23, L is 90. That little square there implies that it's 90 degrees. And we don't know what m is, but the angles in a triangle add up to 180 degrees. So that means m plus n, which is 23, plus L, which is 90, has to equal 180. Subtract the 23 and the 90 over to the other side, and you will find that m equals 67 degrees. Now we know all three sides, all three angles, so this triangle has been solved. Example 2, solve the triangle. First, label the sides with hypotenuse, opposite, and adjacent. This time we know angle R at the top of the triangle, so if I were going to label my sides, opposite or across from R is the point 17, adjacent or beside R is this side on the left, and across from my 90-degree angle is always the hypotenuse. Oh, we should also label our triangle with R, S, and T. Across from big R is little r, across from big S is little s, and across from big T is little t. To solve this triangle, we need to find little s, little t, and big T. It doesn't matter what order you solve for. I am going to find little s first, purely because it's alphabetical order. No other reason than that. To solve for little s, we know the opposite side, and we're looking for the hypotenuse. Opposite, hypotenuse. We know opposite, we're looking for hypotenuse. We want to use the SO fraction. Set up your trig fraction. You can write sine over 1 if it'll help you, because now we need to cross multiply. Since this is a side, we cross multiply to solve. S times sine of 26.7 equals 1 times 0.17. Unlike before, where we had everything on one side of the equal sign was all calculator buttons, this time we have to divide the sine of 26.7 over to the other side because we want to get the S by itself. So when we cross multiply, we then have to divide. Now, little s equals this fraction here, and everything in that fraction is a calculator button. Make sure you're in degree mode and type it in just like you see. So little s is 0.38. Now let's solve for little t. We can use the Pythagorean theorem here if we wanted to, but I am going to use the same SOHCAHTOA cross-multiplying process just so you have a second example of it. Okay, we know the opposite side. We also know the hypotenuse, but in case I made an error here, I like to just stick with what they gave us in the original triangle. So we know the opposite, and we're looking for the adjacent. we want to pick out which fraction deals with opposite and adjacent, and that is the TOA fraction, the tangent fraction. Write tangent over 1 if that helps you, and since this is a side, we want to cross multiply. Again, we're going to have to divide my tangent of 26.7 over to get my t by itself. And now little t equals 0.17 divided by tangent of 26.7. We can type that into our calculator. Make sure you're in degree mode, and you should get that little t is 0.34. You can do Pythagorean theorem here just to double check. 0.34 squared plus 0.17 squared should equal 0.38 squared. Finally, to solve the triangle, we have to know all 3 sides, done, and all 3 angles. Remember, the angles in a triangle add up to 180, so angle R, which is 26.7, plus angle S, this little square denotes 90 degrees, plus angle T equals 180. So we can subtract that over and figure out that angle T is 63.3 degrees. Now we know all 3 sides and all 3 angles. If you remember the original steps that I gave you, in step 3 I said to cross multiply or use inverses. So far we haven't had to use inverses, but here's where that's going to happen. So solve the triangle. We start by labeling our triangle, but what's the opposite and what's the adjacent here? We don't have a theta to begin with, so you can choose. Do I want A to be my theta or C to be my theta? I generally like to stick my angle in the bottom corner of the triangle. You can choose. I am going to use C as my theta. Okay, so label your triangle opposite, adjacent, hypotenuse. I also labeled it little a, little b, little c based off of their angles. I need to find both angles A and C, and I also need to find side B. Let's find angle C first. Just like before, let's look at what we know. We know the opposite side, and we know the adjacent side. So we need to set up the TOA fraction. So tangent of theta, or tangent of C, is going to be the opposite over the adjacent. Now, instead of cross multiplying, we're going to use inverses. If I tried to cross multiply here, I would end up multiplying my 12 with the tangent of C. But when we solve, we're trying to get C by itself, so I would have to just redivide that 12.5 over and undo what I just cross multiplied. So cross multiplying is actually going to just give you extra steps to do that don't help you whatsoever. Also, I cannot just divide my tangent over. If you do that, if you divide your tangent over, how do you type that into your calculator? If I divided my tangent down to the bottom with the 12.5, you get an error because tangent doesn't exist by itself. It has to have an angle with it. And if I decided to do the tangent first, well, that's making 12.5 my angle. And nowhere in this triangle do I have 12.5 degrees. 12.5 is the length here, like feet, inches, distance, not degrees. So you cannot just divide your tangent over. Every time in this class, if you want to separate sine, cosine, or tangent from its angle measurement, you have to use something called its inverse. The notation for that is a little -1 exponent. That's not saying tangent to the -1 power. It's inverse tangent. I know it's confusing because they have the same notation, but you don't really need to understand that yet. You could also see the words arctan. What that means on your calculator is you will be hitting second before you hit tangent, because most likely you have a little tan inverse on your calculator. You just usually have to hit second and then tangent. So every time in this class that we are looking for an angle, we are going to have to use inverses. Every time in this class, when we use SOHCAHTOA to find an angle, we use inverse sine, inverse cosine, and inverse tangent to find our angle. And that tells me that C is 55.66 degrees. Okay, we could repeat the process if we wanted to find angle A, except if we now are finding angle A, these labels are going to switch because angle A across from A or opposite of A is 12.5. And beside A or adjacent to A is 18.3. So my labels could change, but unlike the last two examples where I wanted to show you more and more examples, let's just find angle A by using our good old 180 rule. The notes that I post to go along with this video actually find A using this method and find C by using 180. All right, now that we know all three angles, we just have to find the third side. So to find the third side, you could use the same process we've used in the past two examples. Remember your theta, the way we labeled our triangle is using the 55.66. Or you could use Pythagorean theorem to figure out what B is. I'm going to do Pythagorean theorem. Remember A, B, and C in this case are the A and B are your legs and C is your hypotenuse. So it's not necessarily the same as the A, B, and C up here. The hypotenuse has to be the C value. So in this case, C squared is actually B squared. Now I know all three sides and all three angles. It looks a little messy, but we know all three pieces. And there you go.